Cool. Thanks, Alec. So today I wanted to talk a little bit about Xamarin.Forms 2.x. As Alec mentioned, it's kind of 2.0 came out relatively recently. 2.1 came out last week. So I wanted to talk a little bit about the changes that have happened in 2.0, 2.1. But first I'm going to start with the usual sort of Xamarin background. And before I do that, can I just get a raise of hands? Who knows what Xamarin.Forms is? Okay, that's most everyone. So this first bit can be pretty quick. Who's using Xamarin.Forms? About half the people that know it. Cool. So I'm not going to spend a lot of time talking about why Xamarin. You guys are coming to the user group, so I can get through these slides pretty quickly. But obviously the value proposition that we offer is building apps for iOS and Android and code that you've written for Windows apps and sharing it across all those platforms to speed up your development and get a better reach for your applications. So you can write all of your code in C#, or maybe kind of F#, but F# will improve in the future, and reach a multitude of devices across the iOS, Android ecosystem, and with code sharing, the Windows ecosystem as well. So to quote Summer, with Xamarin, developers combine the productivity benefits of C#, et cetera, to target mobile devices, multiple mobile devices. So to quote that guy from that razor company, they liked it so much, they bought the company. As you already know, anything you can do in any of the native platforms is exposed through Xamarin APIs so that you can access it with C# using Visual Studio or with C# using Xamarin Studio. So whether you're on Windows or on the Mac, you can build native apps for all platforms. For those of you that haven't thought in detail about what's happening under the covers, the iOS stuff works a little differently to the Android stuff. And when you're building complex applications, this can actually be really relevant to the way you structure your code or some of the things that you need to do to make the code work. So if I skip directly to the Android side, the Android stack looks very similar to the stack that you have in your head when you're building .NET on Windows. There's a JIT and there's IL. So your C# gets compiled to the intermediate language, and it actually is compiled, it's JITted at runtime on your phone, so the code is generated and it runs. So you can do things like reflection. You can imagine that the same things are happening on Android that are happening on a Windows desktop machine. The one difference is that little word there, link, which kind of does the opposite of what you might think. When we link your Android application, we're actually taking out all of the code that we don't think you're using. So we're using the dependency graph that's generated at compile time to decide that you're not using the system.xml namespace, for example. And we leave that out of your application. So if you try and reflect on it later, for example, it's not going to be there. So that's something to be aware of. The stack is conceptually the same as happening on Windows, IL, JITting, and running on a .NET runtime, but we've linked away parts of the .NET runtime and parts of your application to save size. So that's something to keep in mind. On the iOS side, it's kind of completely different. So on the iOS side, we take the .NET framework, which is actually mono. We take your C# and the bindings that we've produced to take the Objective-C stuff and make it available in C#. We munge all that together, and we ahead of time compile it to ARM. So what goes to the iOS device and runs is not IL. There's no intermediate language stuff going across there. It's all ARM. So what that means when we're ahead of time compiling is we have to do certain things that we don't have to do on Android and that Windows doesn't do. And an example of that is flattening generics. So if you've created a generic class with generic type parameters, when we're ahead of time compiling it, we actually need to generate an instance of that class for all of the possible generic parameters, if that makes sense. So in general, that's fine. You can use the .NET generic classes, no problem. But if you're defining generic types with lots of potential parameters, so a generic type with a parameter of object, for example, would be a bad idea. Because we'd need to ahead of time compile an instance of that type for all of the possible subclasses of object. And then we do our best to sort of trim them out with linking. But we don't have that problem on Android, and Windows doesn't have that problem because it just jits those classes as it needs them. So at runtime, if it needs to, a generic type of a certain type, it just creates it.
.NET Native, not the case. It's like iOS.
Right. So .NET Native, yeah, people will hit that as well, if they can wait for the .NET Native compiler to complete. So there's differences in the way that your code is affected. So if you're using a lot of generic classes, you could see your download binary size increase. And it won't happen on the jittered Android app. So that's sort of one of the things to be aware of. The difference between the two platforms when you're working with them is to think a little bit about what's happening in our compiler to optimize your code. So if you're trying to optimize for app size, avoid those sort of very unconstrained generics, because the AOT compiler needs to generate all the ones that you might need. So something to be aware of. You've seen this platform stack before. It's really just to help us explain to people where Xamarin fits as a product on top of C# and in terms of an architecture stack. So this stuff, the shared C# code that you write, say that quickly 3 times, shared C# code that you write can be used across mobile platforms and also desktop platforms as well, I guess. You can share C# server code, so your DTOs, if you use those, any sort of business logic that's able to run on the mobile platforms. So you can share code all the way up. You can share it on your server side, whether it's Azure or Linux, Mono, Core CLR. And then you write native UIs. So you write using UIKit over here, and also there's Mac, obviously. You write using XML and the Android view group stuff here, and you write XAML and Windows UIs there. So you write a little bit of native UI, those colored boxes, and then lots of gray shared C# code. And just to give some numbers, because people often ask this, and many people don't have any experience beyond sort of their own experience. So these are 2 applications. We picked 2 that are kind of UI heavy. iCircuit and TouchDraw both have graphic layout designers. TouchDraw is obviously like an object drawing program, and iCircuit is a way to design and simulate circuits. So you can see, even with applications that have a lot of user interface interaction, building a drawing canvas is very UI intensive, they can still achieve a lot of code sharing. So all the business logic, all of the information that the UI canvas is using about what can connect to what, and how to model that, how to save it to disk or whatever, can still all be shared code. And business applications that are doing lots of data access and just CRUD operations in a UI can achieve even better sort of code reuse stats than that. So, and there's also obviously other Windows platforms that you can look at as well. Anyway, that's the preamble done. Let me introduce or reintroduce Xamarin.Forms. So the classic Xamarin mechanism for code sharing is, like I said, right, lots of shared C# and then native UIs for the target platforms. What Xamarin.Forms provides is another layer of shared code, in which you can define your user interface either with C# or F# or XAML, and then have a very thin bootstrap layer for each platform. So you're doing a lot more code sharing because the user interface as well as your back-end stuff can all be written once. So builds. So Xamarin.Forms always offered 40 pages and user interface controls, data binding, an automatic sort of navigation system, so you can do push and pop navigation like hierarchy, you can do master detail, animation API, and the dependency service and messaging center to let you pull in native features in different ways. So we provide documentation on how to use the dependency service to effectively dependency inject native features. Why isn't custom renderers there? And we also provide the custom renderer model so that you can write user interface controls that are native that you can then share functionality using shared code. But as of Xamarin.Forms 2.1, there's also effects, templating, both for controls and for data. Windows 10 support, which was out actually a little bit before Xamarin.Forms 2. And there's more stuff to come, some of which I can talk about today, and some of which you'll find out about in the future. So, to quickly get a view of what Xamarin.Forms code looks like, this user interface that's rendered across all these 3 platforms comes from that one set of XAML. And really, the point for the people that aren't that familiar with Xamarin.Forms that I want to make is, for each of these concepts, like an entry or a button, when you're designing the user interface, there is not a specific button that you're talking about. It's an abstraction, user interface abstraction. And on iOS, it becomes an iOS button. On Android, it's an Android button. On Windows Phone, it's a Windows button. So there are certain things that are going to happen to that button when it's rendered that are particular to each platform. So you're getting an actual native user interface. It's not like HTML5, where these are 3 HTML pages with HTML buttons. And it's not like Silverlight and the old WPF stuff, where we're owner drawing the whole thing. It's much more like Win32, where the actual native controls are being rendered according to that recipe. So the abstract user interface definition gets rendered with native controls on each platform. And the benefit of that is it looks right. It looks like a Windows button, and that looks like an iOS one. Well, not really, because an iOS one would be blue with no background, but it's native control that we've styled that way. So the benefit of that is speed, performance, and user interaction that feels native to the people using the app. So the built-in pages give you a good subset of the kinds of navigation that you're going to want to build in mobile phone applications. Similarly, the layouts borrow in concept from what was available previously in WPF and Silverlight. And the list of controls, while there's 20 or so there, they're very composable within the layouts from the previous screen. So you can create quite complex applications by composing just the set of built-in controls that Xamarin.Forms offers. But as I said, you can also extend them. There's a couple of other libraries that you might not know about that you can use with Xamarin.Forms, because we've only added support for them very recently. But the Cocos Sharp game engine, which is a port of the Cocos 2D animation and game library, can now be embedded inside of a Xamarin.Forms application, so that you can get a cross-platform game view, which might enable you to do some fun interactions. You might not use it for games, you might use it for business data visualization, but that can easily be plugged into Xamarin.Forms. UroSharp is a 3D gaming engine and graphics engine that can let you put 3D graphics, again, whether it's a game or some sort of data visualization, you can pull that very easily into Xamarin.Forms. And SkiaSharp is literally like a week old. And it's a cross-platform 2D graphics library from Google. And so now you've got a much richer than like system.drawing set of APIs to build 2D graphics that, again, you can share across all of the platforms. Now, Windows for that is coming. There's some build issues with it at the moment. But again, you'll soon have sort of 3 much more rich options for doing graphics within Xamarin.Forms that still lets you share the C# code across all the platforms that Xamarin.Forms supports, and embed these as part of a Xamarin.Forms view. So that's sort of some of the things that are going to come, and once they're out, we'll provide more documentation and samples. You'll find some samples for those online at the moment, but that's definitely worth looking at.
Just a quick question. If we start adopting some of these, is there going to be any complications down the track when the Roslyn compiler becomes the sort of standard, or is that?
I don't think so. I imagine that we're going to try and make that pretty seamless. There's certainly no short-term plan to just switch the Roslyn compiler out from underneath what Mono is doing at the moment.
Yep.
Roslyn will make an appearance first in the IDEs to do completion and end refactory like stuff.
Right.
And later there'll be an opportunity for Roslyn and Core CLR to be part of the underlying product. But it will first, it makes its appearance in our inspector preview. If you guys have seen, there's a visual tree visualizer, Roslyn powered, and the inspector tool itself is all Roslyn powered. So it'll make its appearance in those tools first. And there's also an ecosystem of controls from third-party developers. So if you're looking for flat 2D graphs, if you're looking for a data grid type product, you can download those from some of these people as well. So, getting to the meat. Xamarin.Forms 2 came out last year as part of what we called Xamarin 4. And it was kind of a big deal. We gave it the 2.0 name because it was really a pivot in what we were trying to offer. In my mind, it was kind of Xamarin.Forms 3 because for people that have been using it for a while, you recall we made some breaking changes in 1.3 in terms of the way applications were bootstrap loaded. So in my mind, we kind of skipped a version there. But Xamarin.Forms 2 has been like the next big jump. So some of the things that changed were the ability to compile XAML. So previously, the XAML text went down to your device and was read in and parsed, and the user interface was loaded, sort of created on the fly. Now, generally that was fine, but complex layouts, there were performance issues. So we'd always wanted to do compilation of XAML as an option, so you can get better errors at build time and better performance at runtime. And Xamarin.Forms 2 introduces XAML compilation, and so I'll just show you how that works in a second. We also offered a new Android backend. So the old templates that you've been using with Xamarin.Forms up until now uses an Android activity as its foundation, which doesn't support fragments, can't easily support material design, really doesn't have a lot of forward compatibility stuff built in. So what we've added is a new Android backend, and there's instructions on the website to convert over, and templates from now on are going to include this new backend for Android. And what it does is it pulls in the app.compat activity that Google provides and the app.compat libraries so that you can better add material design, fragments, and other things to your Android Xamarin.Forms applications. So I'll quickly touch on what that migration looks like as well, but it's kind of recommended that going forward you convert over to the app.compat backend, and you'll see it in the templates in the future. We also introduced the list view caching strategy. So we'd always tried to virtualize what was happening in list views to make performance really efficient, but we were virtualizing kind of at the native level, so we were reusing the cells that were being passed through, but we weren't always virtualizing the Xamarin.Forms UI that sat on top of that. So complex XAML layouts were being reloaded all the time, even though we were reusing the cell that they lived in. So list view caching strategy has been introduced to let you turn on an additional level of virtualizing. So we're virtualizing the Xamarin.Forms user interface as well. So drastically improves performance of even complex cell layouts. So that, coupled with the XAML compilation, gives you faster list view startup and list view scrolling. We also added a pan gesture recognizer as well as tap and pinch, so we're gradually getting coverage on some of those different gestures that people have really wanted to have access to across all the platforms. And we've added Windows 10 universal Windows platform support across, it's obviously phone and desktop enabled, along with the two WinRT platforms that we have, the phone and the desktop version. So really quickly, touching on how some of those things work or what to do. The XAML compilation, as I mentioned, lets markup errors come up when you're building the app rather than waiting to run it and then getting some error thrown. It improves performance because the graph is compiled ahead of time, and it's opt-in at the moment. So by default, your XAML isn't getting compiled, but you can add this assembly attribute basically to turn it on. That will probably change in future to be the default because it makes sense that you want to see those errors at runtime, and there might be some functionality in future runtime that you want to turn it off. But for now, add this in and test your apps to make sure that they're working well with XAML-C. We'd love to get feedback if something isn't working, and in the future it'll be the default for build and running. Android app.compat this is what the activity looks like if you're using AppCompat. So it's a little more complex than the one you saw before. So the first change is obvious. You're inheriting from a different class. And then we're loading in some additional resources. And this boilerplate is something that we're just going to have to add in to existing apps. It's not something that we could code gen or do on the back end at this point. And new apps, like I said, will have it built in. There's instructions on the web for actually pulling that in, and the other steps that you have to take. But if you're using Forms on Android, I'd highly recommend proactively moving over to the AppCompat backend and testing to make sure you've got it and it works fine. But it then also gives you a lot of options for material design, layouts. Some of the controls will look a bit more modern. The calendar and the date picker, for example, I think are two that have changed. So upgrade and give it a try. And definitely let us know if there's any feedback. List view caching strategy, that's actually just the definition of it. You can set it both in XAML or in C#. So the default is retain, which is actually not recycling. You can set it to recycle to get the improved behavior. And like I said, this is the default for now, but we may switch to the better, faster default in future. So definitely worthwhile turning it on, seeing how your application behaves and letting us know what you think. Yeah. And last but not least for this release, we already had WinRT support from sort of middle of last year. I'm not sure if everyone's familiar with kind of the history of Xamarin.Forms and Windows Phone development. Windows Phone goes back to 7 and etc. But when Xamarin.Forms came out, the only Windows platform it supported was Windows Phone 8 Silverlight. So those old original Windows Phone devices use Silverlight as a development tool, and we built Xamarin.Forms on top of those APIs. Then Microsoft introduced WinRT, which was a different set of user interface elements and backend. So we released Xamarin.Forms support for Windows 8.1 and Windows Phone 8.1 as separate projects. So you can now target, the Windows Phone 8.1 and newer. That stuff will also run on Windows Phone 10. And you can also target Windows 8.1 desktop and tablet devices by incorporating those two project types. So we've had that support for a while. What we added around the Xamarin.Forms 2 timeframe is an additional project type, which is the Universal Windows Platform. So there was a Windows 8 version of that. We don't support that. We have the two WinRT APIs. They're separate projects, phone and desktop. Windows 10, we support the Universal Platform. So you can create one project and it will support both phone and tablet and desktop devices. So if you're really forward-looking and you only want to support Windows 10, you only need to create one project and you'll get phone and tablet included. And you use the same kind of logic that you use on Android and iOS to decide, am I building for a small device or am I building for a large device? There's device idiom, there's ways to determine the screen size and orientation, and basically use that stuff in your shared code in Windows the same as you do in iOS and Android to adjust your layout to be adaptive.
Are these options built into the wizard and the Visual Studio when you say menu?
So these options will be in the next version, like they'll be in the template. There's instructions on the website now to manually add those three, so you can add one or you can add all three. We're still in the process of adding all of our samples, having all of these platforms supported, but you can check those out and the templates will include that going forward. It's worthwhile noting that you must be using Visual Studio to get the Windows projects. So if you're on a Mac, you still only get iOS and Android. And finally, it's been up on the screen, the original Windows Phone 8 support will be deprecated at some point. Microsoft's deprecating the support for it in Visual Studio and the devices themselves. So there's only so much we can keep adding to that legacy support. So if you're deploying Windows Phone 8 apps with the original version of Xamarin.Forms support, you'll want to update it to either RT or UWP proactively. At least get it running and test it and see if there are any changes that you need to make. So that brings us to Xamarin.Forms 2.1, which Alec mentioned. So it brought a few different functions. You can check out the release notes to see more details and Jason's blog. Control templates and data template selector, which gives you templates in list views, and effects. So I'm going to quickly run through each of those. I also want to mention a deprecation, because it's probably one of the most common things that people are going to miss when that happens in future. So if you've done any sort of binding stuff in your Xamarin.Forms app, you've probably done bindable property.create. Any of your view models, if anyone's doing MVVM, you've probably used this code. So the generic create method with the two generic type parameters was bloating user code, for the reason that I was trying to explain earlier when I talked about AOT versus JIT, because these two types are fairly unconstrained. So when we're building your app, for iOS, we're AOTing a lot of create methods, just in case your code needs them. So for that reason, we've taken the method out to discourage people from using it. The equivalent non-generic method is just create, param, and you pass in type of this, type of that, and you get exactly the same functionality. So it's probably worthwhile going through your code base and looking for this and just adjusting it to the non-generic version. Your app size will go down. It'll be functionally the same, but you'll be prepared for a future version where that method isn't available. So a little bit of a tip for a future kind of deprecation altogether. So control templates. This is something people have been trying to do for a while. A lot of people have been diving into native land, so trying to write a custom renderer to get this sort of functionality. So it's actually made up of some fairly fundamental changes in the Xamarin.Forms view hierarchy. So in the past, basically the two roots of the Xamarin.Forms control hierarchy were a content view and content page. And everything kind of sprung from those. All of the page types are content page. All of the control types are content view. So this functionality introduces a template page and a template view below the old classes in the hierarchy. So now, because of that, you can automatically template a content page or template a view. So a template is generally found in a resource dictionary and generally defined in XAML. It's possible to do in C#, and we have an example for that, but you're probably going to want to do it in XAML. So in your application resource dictionary, here is our first control template. And it's going to be a grid. Grid's quite useful for laying out stuff like this. And you can do anything you like in the UI for the control template. So you can put headers and footers, you can put controls, you can put stuff around. The important thing is that somewhere in there you want to put the stuff that you're templating, like the actual thing that you're trying to wrap. So the content presenter, in this case, goes right in the middle. So this template looks like this. So we've really just created a header and a footer, which is like so HTML, it's not funny. And then we've created a big white area where we're saying, whenever we use this template, the Xamarin.Forms content is going to go in here, and we're always going to have this header and this footer. And it's it's using these properties to know how to size itself. So to use it, like I said, content view now inherits from the templated page, or templated view. So we can automatically just assign its template. And then we put in, whatever we want to be in the template, like so the rest of the page. And this is what it looks like on all three platforms. This stuff the header and the footer, comes from the template. And where we had content presenter in the template gets the contents of the content view. So the button and the label.
So you're still having to say though in the content view there, center and expand. That's not a sort of an assumption. So stack layer, vertical option, center and expand.
Yep.
You're still having to put that in your content as opposed to it being part of the template.
Yes, because we set this up with those grid, like height and width. If you'd set it up so that it was always at the top, for example, then it would always be at the top. There's definitely some interaction there between you determining how you want the children to be laid out. But if you wanted them to always be at the top, you should probably use different grid, row and column values to force it up.
Because there wasn't the star, which is like the filler for the grid in the previous template.
Yeah, the grid is set up actually for that to be taking up all the space, and then within that, the view itself is having its own layout.
So basically, it just joins the XAML together.
Yeah, but it does gives you the ability to. There's some more complex examples that have come up on the website to help you figure out sort of affecting the template from the page. So
examples of button, because it's got a control template, it's got some brand content inside another button. Well, make it still right.
Yeah, so these are native buttons though, so that's not going to work as easily.
Well, I have a question though.
Yeah, please.
Other than a statement, how does this go with the compilation stuff? Do the resource dictionaries compile? Or
Yes, so if you've got XAML compilation turned on.
for the entire assembly?
Yes. Yeah.
Is there a way to turn it on just for resource dictionary? Or you have to put it in
There, I
assembly?
think there is an attribute, so that assembly attribute is the one that we've been telling people to use. I believe there is a way to turn it on in the page, like just attach it to that control. Yeah, Mike's saying so you can do that. Probably,
The resource dictionaries are not a control, you'd have to turn it on.
you'd have to turn it on for the, well,
Assembly,
it's,
wouldn't
you're attaching it in the application class though, so in the code behind it, the application class maybe.
So fair
Yeah.
enough,
But you probably want to have compilation turned on for everything. But yeah, if you want to test things out, So that enables like all these new scenarios for applications that have common headers and footers, or maybe I don't know if it really suits white label, but it certainly lets you pull apart some of your separation from your logic in terms of layout. So that's worthwhile. Kind of related, but kind of totally different, is the ability to choose different templates for list view, so data templates. So I've just included a really simple copy and paste from our sample on the website. So in your list view control now, you can set your template, instead of being to a template that's defined in your resource dictionary, set it to a data template selector, which is a class that can be as simple or as complex as you like, that decides based on something in the content which template to use when it's rendering. So at the simplest level, you could have an alternating thing where it goes odd even, or in the example that we've got on the website, it's actually just choosing to display it in a different color based on some value in the control. But you can create templates as complex as you like and use them selectively as the list loads and is scrolled. Yeah.
I think it would be quite interesting to go on the even one there, because the callback doesn't include the index of that.
Yes, it might be interesting.
Oh, but you can put it into the list.
I learned this recently. If I make the view model that it gets passed into it, that it just has a number
the
on it.
calculation.
Yeah.
Thus break
Put the index in.
Right.
So at the end of one hit.
Yeah, there's no intrinsic index available for things like mod2, but
That's always been a sore point, I think, coming from iOS, because iOS makes that sort of thing very, very easy. So if we can go into the framework and actually be indexed as well as passing the item,
right, yeah,
the iOS just makes it really easy to do that kind of effect.
yeah. Well, at least you can do it in Forms
Yeah.
with this functionality. But yeah, the view model would be the place to expose an integer that you could switch on if there wasn't something intrinsic in the data.
If you store it in the data template selector, say that you got 13 items, right, an odd amount of items, and let's say you redraw the page using the same data template selector, you would find every time you redraw, because it's an odd amount of items, it would flip. One would be dark, next time you load it, that would be light.
Yeah.
This one would be dark, light, dark, light.
Yeah, I would be wary of using the data template selector to
Don't
cache that
store
stuff.
private stuff in there.
Yeah, yeah, use the view model, always. And so lastly for this release, or for this section, I want to talk about effects. So effects are like custom renderer light. So for the people that aren't that familiar with Xamarin.Forms, a custom renderer is effectively letting you build a renderer exactly like what the actual underlying framework does. So we've created renderers for buttons and list views and list boxes and edit boxes and so on. And we've written the code that creates an edit box and assigns properties and lets you bind things to change its appearance. If you want to change the behavior of Xamarin.Forms for a specific control on a specific platform, we effectively say to you, subclass that or write your own and implement all that stuff. Which is great if you want to do all that work to really fine-tune the behavior of a control. For example, you just want your iOS control to do this stuff. But what it's kind of overkill for is if you just want to change the outline or change some property that's native to the platform that Xamarin.Forms doesn't expose. We make you do all this work to effectively put an underline on a text box or something. I don't think we have underline natively in Forms. So effects are like a light version of a custom renderer. You can only change properties on the native controls, but you build the effect in the native platform. So for an iOS control, you build it in the iOS project, and then you have access to all of the properties that iOS provides, for example, for the edit box or for the button. So you can do anything that the native platform would allow you to do to change the properties of that object, for that user object. So they're stringly typed, which is how we let you define it totally in the iOS project, but still refer to it in the shared code. So you give it a name, which is a string, and then you refer to it that way, so that the shared code compiles and runs and doesn't really know about the effect, except that it can be loaded by its string name at runtime. So that's the sort of the interaction mechanism that lets it work. But it's not a custom renderer. You don't start overloading events or adding methods or overriding methods in the control itself. That's what the custom renderer remains for. It's purely to help you tweak the user interface, get access to properties that you wouldn't otherwise have access to in a really simple way. So effects are not for replacing the control. They're for fine-tuning user interface and really getting the exact look that your designer has asked for example, without going full custom renderer. So it's also much quicker to iterate over.
So like the XAML, the stringly type stuff, does that get type checked with the ahead of time compiler?
I do not think so. Certainly not at this release.
So you really need to...
If the effect doesn't have any effect, then yeah, the string is probably wrong.
Oh, okay, so it's not going to crash anything.
No, so the good thing about it is it's optional. So you don't have to implement it for all of the platforms that you're supporting.
Yep.
If you just want to tweak the iOS edit box, you can create an effect for it.
Yep.
You can add that effect in your shared code, and on iOS it will get applied, and on Android the effect won't resolve to a known thing, and it'll just be a no-op. Okay. So yeah, so you're not required to do it for all three platforms, and it won't crash if you don't. So here's a really simple implementation of one. So border effect inherits from platform effect. This is an iOS specific effect. So basically what I'm doing is saying the control will have a layer property, and when I'm doing this in the iOS project, that stuff will autocomplete. So I'm setting the purple color, the border width, and then on detached, undoing what I was doing on attached, so that if the effect turns on and off, it resets it back to normal. So that's the iOS specific effect. Because I don't care, maybe on Android it's already purple because of material design. So I just want an iOS to create this effect. And then for my entry control, there's an effects property collection, add effects resolve the stringly typed name.
Can you do an example?
Yes. But it's, yeah.
Let me find any samples of an example here.
So I think some of the documentation for this is being held up on review, but it's going to be out like imminently. Then there'll be some samples as well, like some official ones. I know Jason already did his blog post. We still go through our sort of edit and review process. So
Can you strongly type that platform effect?
I don't know. I'll have a look. We can have a look at the code afterwards and check it out. So yeah, that gives you a much kind of more finely grained way to tweak the UI, but without all the overhead of creating a custom renderer. And like I said, there are samples and documentation coming for this stuff. So check out Jason's blog that was linked earlier, and come back to developer.xamarin.com in a day or two. And that's Xamarin Forms 2.1 and 2.2. I was kind of hoping to be able to talk about the next version, but it hasn't hit pre-release yet, so that's a shame. But you should, if everyone hasn't already, please check out Charles's book. Most of the chapters are online as PDF, and even though I think people are aware of it, if people have attended conferences and someone in the past, you might have seen it. It's often the answer to people's questions. Like, I'm continually referring people to the chapter on sizes and the chapter on fonts and the chapter on various other things. So if you haven't checked it out and you're interested in Xamarin Forms development, I would recommend, like I've read it from start to finish, but it's worthwhile looking at in addition to the searchable docs on the web, because it's Charles. He does a great job of explaining not just what it is, but how it works. And we're adding more chapters all the time. Nobody cares about that stuff. But Xamarin.com, you can get the stuff. Evolve.xamarin.com if you're interested in coming to Orlando next month. Otherwise, I'm going to leave it there and take any questions related to Xamarin Forms. Thank you.
I've been using Xamarin Forms more or less since it came out. One of the things I'm finding is that the stock controls are often very hard to subclass because they've got bits of them that are actually either private or internal.
Mm-hmm.
It's quite frustrating at times. For example, I had to secure a web area recently, and in order to do that, I had to subclass the whole thing, including all of the internal classes, and bring them out of the assembly and make my own versions of them, which seemed to me to be a bit of a waste of time.
Yep.
So I was wondering, is there going to be some move towards reducing the amount of internal stuff?
So the question was about subclassing, creating custom renderers for controls, and the fact that a lot of the stuff is internal and hard to discover, and therefore hard to write a working subclass. So I guess there is a shorter term and a longer term explanation, or where we want to go with that. Shorter term, we've started to write samples of basically custom renderers from scratch. So for those complex controls, not really recommending that you subclass our renderers at all, but write a renderer for a view, and then putting the web control in or putting the map control in and actually re-implementing it. Because you actually have more control. You can pull in code from native Xamarin samples or stuff off the web, and you spend less time fighting stuff that you can't see. Or if someone was to use Reflect to use code that they're not supposed to be using, we're really saying that we understand that's hard, and we've been trying to add more samples. So if you go to developer.xamarin.com, we now have a WebView sample that's from scratch custom renderer, a map sample from scratch custom renderer, and we've started to try and provide those as a better starting point. So between effects, as a way to tweak the control's appearance without a custom renderer, and actually starting with a view custom renderer and then just pulling the whole thing in. I think those are the two short-term ways that we'd say, get around that. And longer term, you'll find out something at Build or at Evolve.
gotten so much better since 1.4 to 2. One of the most common things I found annoying in 1.4, even still now, is everything is sealed.
Yeah.
And you look at you double click the mono, you have a look at how it's been implemented, and go, that's one line that I see the mistake right there. I can't change it. All I can do is
Yeah.
beg to Xamarin support.
Yeah.
That is a huge
Or you have to
frustration.
copy the whole of the custom renderer from the...
Yeah, so we don't want, I mean, we understand that that's a problem. We obviously, we don't want you to do that. We want to provide easier ways where there's less mystery under the covers. So to give you some background, or you probably already realized the background is building a platform from scratch. The more open it is, the less choices you have as it grows. Because once you've opened it up and people rely on that inherited behavior, you can't change it. So Xamarin.Forms 1.0, there was a lot of stuff sealed. And some of the stuff that was open shouldn't have been. Like the intention was actually to lock it down more. The team is, cognizant of the way people want to use and extend Xamarin.Forms, and so you've seen stuff starting to open up. But when we hear people having these problems, we're also trying to figure out, not what people are asking to do, which is, we want this unsealed, is what are they trying to do in providing a better solution. So effects is one of those things where people are asking, we need to have custom renderers easier because we want to tweak this field. It's like, well, actually, we can do it better for you. We can provide this API, which is even simpler, that does what you want to do. So we're always kind of balancing those two things. But the product is continuing to grow, and there'll be more announcements about the next version, which I couldn't talk about today. That I think people are going to continue to be excited. If you're happy with what happened from 1.4 to 2, you're going to be really happy with what happens in 2.x.
What would be the obstacles or issues with using Xamarin.Forms down the track to generate a web app, so that you can target people who don't have,
I think the same really as any sort of generic user interface layer is how much you can have your view models and your data access stuff isolated. Any web app isn't really easily converted to a single user mobile or a device app, and vice versa, because you have that one user versus many users conundrum. So you actually have a slightly different authentication mechanism and a state mechanism. But things like your business objects and some of your business logic potentially could be moved back and forth. And if you're designing that in advance, you can probably do a fairly good job of making it reusable. But the key things are the user management and state management. That stuff varies a lot from a web backend to a single user device app. But it's certainly possible because it's all C#. Any more? Okay, great. Thanks everyone for coming. Oh,
One question.
yeah.
You mentioned about application size and generics.
Mm-hmm.
Do you get the same size problem with the dynamic type?
So the dynamic type isn't actually possible in Xamarin iOS. So you would if you could probably, but it's just not even an option because we can't AOT enough. Dynamic is so open. So if you try and use it, depending on the version of, you might be able to get it running in the debugger, but you'll never get it running on a device.
I thought I had it running on the device.
It should not run, but it definitely will run on the simulator because we do a different build for what happens on the simulator, what happens on the device.
Frank does his UI continual refresh bit.
Yeah. Yeah. So yeah, it would. I mean, that's the thing with dynamic. It literally has to be done it has to be jittered because you don't know what's going to happen with the classes. But yeah, there's a bit of a trick that you can get it running on Android because the jitter is there, and you can get it running on the emulator potentially, but shouldn't be relied upon for production app at the moment. Okay. Oh,
Sorry. You mentioned that there are limitations for what you can do with F#.
Yep.
In Xamarin. Can you just summarize that?
So the real limitation is with our currently released product. There is no template for Xamarin.Forms that includes F#, and there's syntax highlighting. There's some issues with F#4. Just our team working really hard to try and get F# support up to the same level as Visual Studio. And the release that you're looking at now that's currently stable is a few months old in terms of its original version. We released that Xamarin Studio 6 on a 5 last year. So the version of Xamarin Studio you can actually download now in our alpha channel is significantly improved. And if you go to the release notes section at developer.xamarin.com, you'll see a page of improvements to the F# support. We have PCL support for F#, we have shared project support for F#, much improved autocomplete engine. There's a Xamarin.Forms template, as well as iOS and Android templates. And that release will move from alpha to beta to our stable channel. So if you're interested in F# and Xamarin.Forms, I would just go straight to the alpha release and start playing around with it there, with a view to looking at it more seriously when that release is in production. Alternatively, you can do it all. You can use Xamarin from F# with Visual Studio and have a lot of success with it, and people are already doing that.
One of the things I'd like to be able to do, talking about F# templates, is also to create my own Xamarin.Forms application templates. Because there's a fair amount of boilerplate that needs to go into an app, and sometimes if you're doing apps of the same type, you want a template that just puts them all in for you.
So the question about templates, I don't actually know what the extensibility story is. I'm not that familiar with Visual Studio. For Xamarin Studio, people are creating templates using the Xamarin Studio add-in. There's an add-in, instructions for building add-ins on our website, and I believe you could use that, because that's what we did for the Coco Sharp templates.
There is a Visual Studio add to the V6 template. You can create a project that creates one of those. And it's fairly straightforward to do it for a project. It's quite a bit more involved to do it at solution level with multiple projects in it.
There is a very awesome plugin for Visual Studio called Sidewaffle, which provides a bunch of stuff. So instead of writing a Visual Studio plugin, you just do the Sidewaffle solution layout type thing, and it handles all that junk for you.
Cool. Check it out. Okay, I'm going to stop now because you know what time we're supposed to do, but Alex standing up, so thank you.